In the ever-evolving world of software development, quality reigns supreme. Dromey's quality model stands as a beacon, guiding developers toward building truly excellent software. This model provides a structured framework for understanding and achieving software quality. It emphasizes 6 key dimensions that collectively contribute to a holistic definition of quality. This essay delves into the depths of Dromey's quality model, exploring each dimension and its significance. We will uncover the importance of correctness, reliability, robustness, usability, maintainability, and efficiency. By understanding these dimensions, software developers can create high-quality software that meets and exceeds user expectations. Dromey's model is not merely a theoretical concept. It has practical implications for software quality assurance, SQA, practices. Throughout this essay, we will examine real-world applications of the model. We will also explore how current SQA practices can be improved by incorporating the principles of Dromey's quality model. By embracing Dromey's model, software development teams can elevate their craft. They can deliver exceptional software that stands the test of time. This model is an invaluable tool for achieving excellence in software development. Correctness refers to the degree to which a software system meets its specified requirements. It is the foundation upon which all other quality dimensions are built. Software that does not function as intended is inherently flawed, regardless of other positive attributes. Evaluating correctness involves rigorous testing and verification processes. Developers employ various testing techniques such as unit testing, integration testing, and system testing to ensure that the software behaves as expected. Code reviews and static analysis tools also play a crucial role in identifying and rectifying defects. The impact of correctness on software development is paramount. Software defects can have significant consequences, ranging from minor inconveniences to catastrophic failures. By prioritizing correctness, development teams can minimize the risk of errors and deliver reliable software that inspires confidence in users. Furthermore, correctness is not a one-time concern. It requires ongoing attention throughout the software development lifecycle. As software evolves and new features are added, it is essential to ensure that existing functionality remains intact. Regression testing and other maintenance activities are crucial for preserving correctness over time. Reliability is the probability that a software system will perform its intended functions without failure for a specified period. It is a measure of the software's consistency and dependability over time. Reliable software operates predictably and consistently, instilling trust in its users. To assess reliability, developers use techniques such as statistical testing and fault injection. Statistical testing involves subjecting the software to a large number of random inputs to identify potential weaknesses. Fault injection, on the other hand, simulates failures to evaluate the software's ability to handle them gracefully. Reliability is crucial for software that performs critical functions, such as controlling aircraft or managing financial transactions. In such systems, even minor errors can have severe consequences. By focusing on reliability, developers can create software that operates flawlessly under pressure, ensuring the safety and well-being of users. Moreover, reliability is closely linked to user satisfaction. Software that crashes frequently or produces inconsistent results can be frustrating and erode user trust. By prioritizing reliability, developers can create software that delights users and fosters loyalty. Robustness refers to a software system's ability to cope with unexpected inputs or conditions. It is a measure of the software's resilience and its ability to handle errors gracefully without crashing or producing incorrect results. Robust software can withstand unforeseen circumstances, maintaining its integrity and functionality. Evaluating robustness involves testing the software with invalid inputs, unexpected data sequences, and other abnormal conditions. Stress testing and load testing are also crucial for assessing the software's ability to handle extreme workloads or resource constraints. Robust software remains stable and operational even when pushed to its limits. The importance of robustness is evident in systems that interact with the real world, where unexpected events are commonplace. For instance, a network router must be able to handle sudden spikes in traffic without dropping packets or crashing. Robustness ensures that software can adapt to changing circumstances, providing a seamless and reliable user experience. Furthermore, robustness contributes to software security. Malicious actors often exploit software vulnerabilities by providing unexpected inputs or exceeding system limits. By designing robust software, developers can mitigate the risk of security breaches and protect sensitive data. Section 5. Usability, putting users at the forefront. Usability focuses on the ease with which users can learn, operate, and interact with a software system. It encompasses aspects such as the software's user interface, documentation, and overall user experience. Usable software is intuitive, easy to navigate, and efficient to use. Evaluating usability involves user testing, where representative users interact with the software and provide feedback on their experience. Heuristic evaluation, conducted by usability experts, identifies potential usability issues based on established guidelines. Usability testing ensures that the software meets the needs and expectations of its target audience. Usability is paramount for any software intended for human use. Software that is difficult to use can lead to user frustration, errors, and reduced productivity. By prioritizing usability, developers can create software that is enjoyable to use, empowering users to achieve their goals efficiently. Moreover, usability is essential for software accessibility. Software should be accessible to all users, regardless of their abilities or disabilities. By considering accessibility guidelines during the design and development process, developers can create inclusive software that everyone can use. Section 6. Maintainability, planning for the future. Maintainability refers to the ease with which a software system can be modified, enhanced, or corrected. It encompasses aspects such as code readability, modularity, and documentation. Maintainable software is easy to understand, modify, and extend, reducing the cost and effort required for future maintenance. Evaluating maintainability involves code reviews, static analysis, and other techniques that assess the software's internal structure and design. Well-designed software exhibits high cohesion and low coupling, making it easier to modify individual components without affecting others. Maintainability is crucial for the long-term success of software systems. Software rarely remains static after its initial release. As user requirements evolve, software must be updated to incorporate new features, fix defects, and adapt to changing environments. Maintainable software can be easily modified to meet these evolving needs, extending its lifespan and reducing the total cost of ownership. Furthermore, maintainability is essential for knowledge transfer within development teams. When software is well documented and easy to understand, new developers can quickly come up to speed and contribute effectively. This reduces the risk of errors and ensures the continuity of the software development process. Section 7. Efficiency, optimizing resource utilization. Efficiency pertains to a software system's ability to utilize computing resources effectively. This includes factors such as processing speed, memory usage, and storage requirements. Efficient software performs its tasks quickly, consumes minimal resources, and avoids unnecessary overhead. Evaluating efficiency involves performance testing, profiling, and code optimization. Performance testing measures the software's response time, throughput, and resource utilization under different workloads. Profiling identifies performance bottlenecks, allowing developers to optimize critical code sections. Efficiency is crucial for software that performs computationally intensive tasks, such as data analysis, image processing, or scientific simulations. In such applications, even small performance improvements can significantly reduce processing time and enhance overall system performance. Moreover, efficiency is essential for mobile and embedded systems, where resources are often limited. By optimizing software for efficiency, developers can extend battery life, reduce device heat, and provide a smoother user experience. Section 8. Real-world applications, Dromey's model in action. Dromey's quality model finds practical application in various software development domains. In the realm of safety-critical systems, such as those found in aviation or healthcare, adherence to the model's principles is paramount. For instance, avionics software must be highly reliable, robust, and efficient to ensure passenger safety. In the world of web and mobile applications, Dromey's model guides developers in creating user-friendly and responsive experiences. Usability and efficiency are crucial for engaging users and retaining their attention. E-commerce platforms, social media applications, and online gaming platforms all benefit from the model's emphasis on user satisfaction. Furthermore, Dromey's model is relevant in the development of enterprise software solutions. Maintainability and scalability are essential for systems that support complex business processes and manage vast amounts of data. Customer relationship management, CRM, systems, enterprise resource planning, ERP, systems, and data warehousing solutions all benefit from the model's focus on long-term sustainability. Section 9. Improving current SQA practices. Dromey's quality model provides valuable insights that can enhance current software quality assurance (SQA) practices. By integrating the model's principles into the software development lifecycle, organizations can elevate their SQA processes and deliver higher quality software. One area for improvement is the early and continuous involvement of SQA professionals throughout the development process. By collaborating closely with developers from the outset, SQA teams can ensure that quality considerations are addressed at every stage, from requirements gathering to deployment. Another area for enhancement is the adoption of automated testing tools and techniques. Automation can significantly improve the efficiency and effectiveness of testing, allowing for more comprehensive coverage and faster feedback cycles. Furthermore, organizations should foster a culture of quality within their development teams. By promoting quality awareness, providing training opportunities, and recognizing excellence, organizations can empower their developers to prioritize quality in their work. Section 10. Conclusion: a holistic approach to software quality. Dromey's quality model provides a comprehensive framework for understanding and achieving software quality. By considering all 6 dimensions: correctness, reliability, robustness, usability, maintainability, and efficiency, developers can create software that meets the highest standards of excellence. The model's emphasis on user satisfaction, long-term sustainability, and continuous improvement aligns perfectly with the goals of modern software development. By embracing Dromey's model, organizations can deliver exceptional software that delights users, adapts to changing needs, and stands the test of time. In today's competitive software landscape, quality is not a luxury, but a necessity. Dromey's quality model provides the roadmap for achieving and maintaining high-quality software standards, ensuring that software products meet and exceed user expectations. By adopting the model's principles, organizations can gain a competitive edge and establish themselves as leaders in software excellence.